means that we already work on it for this last 2 years. An important aspect of this project is that it is based on open source technologies. And the goal is to develop solutions that can easily be replicated in other water utilities. We already used GISWATER in Manresa, in the water company. So we continued and took advantage of this PERTE project to add new functionalities in GISWATER and also to refactor some functionalities that already existed, which is the goal that or the purpose was to get a solution that is fast. So I will not enter into the details. I will let then David to explain step by step the water sips today. What I would really like to insist is that, for instance, it will be you will see the what map zones in GISWATER are. I don't know if you are familiar with of examples of sorry, I forgot about the to start. So this is about our PERTE, and let's skip to the SIPs now. And I was saying that David will explain in detail and in the details, among other features of this GISWATER, also the map zones. But what I would like to insist and to give the example is that, for instance, an example of a map zone is the district area, district matter area, or the press zones. In our company, we have around 400 district matter areas or 400 press zones that can easily be being changed according to the valves that are opened or closed. So they don't have a static geometry, and we want to be able to calculate these map zones in a very fast way. I would like to insist that with this new version of GISWATER, we can calculate all the map zones in around 16 seconds. So we can check them, see if they are correct or not, and repeat the process because it's fast. Or another example that I will just like to talk a little bit about, I would like to talk, it's about a MinCut. What a MinCut is, it's what happens with a pipe is broken. Again, normally when a pipe is broken and we have to act quickly on, and we are out, and maybe the cover the signal of our internet it's not very strong, so it's very important the response to be very quickly, and in this way we can see very fast which are the valves that we have to close and see the area that it's without water. And with this new refactor, we can have this process in around 1 second and 3 seconds, which is great. And also because of this speed, we can get a massive MinCut if we need the results for our studies. So as you can see, and these are just some examples I gave for the water. Without insisting again, for the urban drainage, a quick map zone that it's very important. It's the draining zones that we can have them in dry weather or in the with the rainy weather. And this combined with the fact that we can calculate the fluid type and the treatment type of our waters inside the network using the propagations, gives us a very strong tool to know for every point, every outfall that arrives into the environment, what's the type of the water that arrives, and the water that brings it from where comes. So without talking into more other details, I will let David to show you other features. And yeah, what I really would like to say that this GISWATER tool is a real very powerful tool, not because it's made with open source software, is also because it has a really very um, smart algorithms in the back for a smart analyze of our networks. So thank you.
Yes, thank you, Claudia. I think now, David, you should be able to control the screen.
I should, but oh yeah, I finally managed to enable the mic. Perfect.
Okay.
So hello everyone. My name is David Cano. Thank you, Namu, for your presentation. Before starting with the demonstration, we will go into a little bit of the timeline of GISWATER. So basically, it was born in 2014. It was a very primitive and simple concept back in the day, mostly focused to hydraulic models. Then in 2016, we had some international connections, intercontinental connections, in fact, with Brazil, and they were interested in the tool and they helped finance the 2.0 version. In fact, this client in Brazil, Saneago, is, I believe, the biggest water utility that uses right now GISWATER with over, I don't want to be wrong, but over 1 million people for sure, maybe over 10 million. Let's not risk it here. Then version 3.0 came with Aguas da Mataró. It added a lot of depth to the tool, and now in 2025 last year, we released version 4 with Aguas da Manresa financing. And well, you will see what the tool is all about now, but it's been a long process. It's been more than 10 years of development, so it's not something that happens overnight. And obviously, it's a very complex tool. It takes time to get to know all the features, and it takes time to uh, get the workflow because maybe you understand what you are doing, but the workflow is very particular. So today we are going to try a little bit of an introduction, a little bit of a test, and let's not get in depth with anything because obviously it would take much more than half an hour for this demonstration. First of all, the architecture of GISWATER. It's very important to understand what we are connecting and what we are working with here. So in the middle, we see the database schema in PostgreSQL. It will contain everything that we need in order to work, and different components that we can connect from the outside or going from this database to the outside. So this acts like a bit of a middle ground. We can connect with EPA software with hydraulic modeling. Obviously, QGIS is the way to visualize all this information and to work actively. We don't work outside of QGIS. We can also run models and interpret results in QGIS, so we don't even need to open the EPA software. And then we can connect with other tools like Power BI for company management, maybe with SCADA or QField for field operations, and BMaps, for example, a software that was used in Mataró for visits to maybe add pictures and add certain information to the visits that the field operators are doing. And this is more or less what the cycle would look like in GISWater. We start with an asset inventory. It needs to be topologically very correct. So we need to edit the network, we need to polish everything, we need to make sure that the data is real, and we need to compare with maybe older data models that existed, or in field operations, opening registers. Then we can add, in terms of operations and management, visits and events. So, for example, in a particular manhole, for example, in urban drainage, we can add one visit if somebody went there and took pictures and measured the depth, for example. Then we can also do the min cuts and the flow traces that Claudia was talking about. We can approximate with a lot of detail what valves we need to close in order to repair leaks, and we can see where the water is coming from and where the water is going to, especially useful in urban drainage. Today, I didn't mention, but we are focusing on water supply. I'm just mentioning these things. The demo will be only water supply. If you're interested in urban drainage, there will be a demo tomorrow in Spanish. We don't have time for both, unfortunately. This profile tool is exclusive of urban drainage, very useful to see the shape of the pipes and the shape from one manhole to another. Then we can also link documents and images to every single asset that we have in our network. And then when we have all of these, when we have all the topology and we have somewhat of a calibrated network, we can run a hydraulic model with IPANET or with SWIM. And finally, another capability that's probably the one of the biggest highlights of this 4.0 update, the refactor that has been to master plans and budget. We will not go in depth because this is truly complex, but basically we can planify renewals, and we can planify new pipes and new sectors and new stuff, and we can all have it separate from the network in production. So we can have a corporate network that we have hydraulic models and everything, and then we can have our planified network that's not executed and that sometime in the future we will do. So that would be everything for the slides. And now we can move on to the demonstration. You have to excuse me because my Zoom is malfunctioning, I believe, and I don't know
I think
if
now
I
you
can share
can,
screen.
yes, you should be able to wait. Let me stop the remote control, and then if you try to share your screen, you should be able to.
Fantastic.
Yes.
Yep,
Yes, now we can see yours.
perfect.
Perfect.
So this is the environment of GISWater. We have a sample here with two exploitations. This is one exploitation and this is another. This is not real data, and nothing that is in this sample is real because obviously for privacy reasons, it would not be ethical or legal. And first thing that we need to do and we need to take a look at would be the network inventory. So we come here. We can see we have a water network here. We have some valves, we have a flow meter here, hydrant, some pipes, some junctions, closed valve in red, for example. So first of all, what do I do with this? I need to understand that this environment is not only for me. So if I want to deploy in a corporate, I have other people that are working with this same project, same database. So if we right click here, we can see GISWater, Basic, Edit, IPA, Master Plan, OM, and Utilities. These are the toolbars, but these are also associated with database roles. So we can create a corporate hierarchy. Maybe there will be an admin or a manager that will have access to everything and will be able to do all the processes. Then we have a technician that is only in charge of drawing and will only have edit features available. Then we have a field operator that will only have operations and management enabled. Then we have an engineer and they will only have hydraulic model. So we can customize everything and we can set different roles for different people to have access to the tools that they exactly need. It is possible that we have a super user or somebody who has access to everything, but not necessarily everyone. So now starting with GISWater itself. So when we have this structure created, no, I am the end user. Maybe I am the administrator, so I will have access to everything here. First thing I need to do, I need to check. I need to see what is going on. What do I have? What's my inventory? The first step that we saw in that workflow. So we have this tool, GISWater information. I can go here, I click on this hydrant, and we have a pop-up here. In this screen, we can see all the data that we have in this hydrant. And this is one of the key strengths of GISWater. We can also see the hydraulic model information in this dialog. So we can switch to the IPA tab and we can see here. IMP information, we can set some custom values. RPT information, the results are shown here. We have other tabs like elements. We can insert elements or events or documents or budgets to this element or to this asset. But right now, it's not important. The main thing is that in this tab, we can control everything related to this one element in particular. So this brings us to the main dichotomy of GISWater. Here we have the styles button and we will see GISWater basic. This is what we have enabled now. But we also have the IPA world. If I click here, hey, symbology is changed. This is representing all the objects that will go to hydraulic model. So with just 2 clicks, we can see, hey, inventory side, this is what we have. We can edit everything. We can tweak parameters. We can change topology. We can draw anything. And then when we have it all clean and perfect, maybe I'm interested to see, hey, this junction, it's not going to the hydraulic model. I don't care. So we switch to this view and we see exactly what is going on in the hydraulic model. For now, we will work with the basic symbology because it's more useful for most of the features that we will discuss. Basically, with this info, we can do what I just explained, but we also have another function that's very interesting. We can close valves with the info. So if I right click on top of a valve, I'm too far away. Now, I right click on top of a valve, close valve. You see, if I close, it turns red. And now you will not see it if I change the IPA world, but this is also going to hydraulic model. So if I edit this valve and I open it right now again, the hydraulic model at the same time, in real time, it's capturing this information. So it will close this valve. Next toolbar. Well, the edition. Well, before that, we can take a look at the filters, also very, very important feature. The filters, we have selectors here. If I uncheck this, you will stop seeing the exploitations. If I only check one, you will see exploitation 1, but if I zoom, the second has disappeared, and vice versa. If I check the second, the first one has disappeared. And this is the same with all the other selectors. So sectors, we can enable or disable sectors in particular. And then state, we can see maybe the obsolete pipes that we could have. We don't have any here, but these are the states of the elements. We have the planified, we have the operative, and we have the obsolete. So operative, obviously, it's what we have. Planified, it's what we want to have. And obsolete, it's something that we had, but we no longer have. So with this check, we could see that. Then we can also select scenarios for planified sectors and for demand, which we will see a bit later. And we can also search features with this tool. So this is the basic concepts of GISWater. We have two worlds. We have information about both worlds in the same dialog with different tabs. We can search features, and we can use these filters to sort all of our exploitations or pipes in different state or the sectors that we want to planify. And now we move to the edit part. Maybe the nitty-gritty for most people. No, when you have to draw the network, when you have to develop something, when you don't know what there is and you need to make changes or corrections, or drawing is the ABC, let's say, of GISWater. We will do a test here so you can see uh, a bit of different capabilities that this tool has. First off, insert nodes. We can insert all these different nodes and catalogs that we have. They are all contained in the database. We will insert a T. T is a junction with 3 entry points. And we will insert it right here. As you can see, this tab pops up. We have to insert a catalog here, which is going to be this one, for example. And we don't have to do anything else. We could fill all this information, but in this case, it's not important. We don't have any of these data points. So we just accept. And look at this. We have this item right here. Next, we can insert a pipe. So we will connect this with this endpoint. Right click, another dialog, and what pipe do we want here? Maybe we like concrete, for example. It's not this catalog, okay, then some plastic pipes. As you can see, this 63 diameter, the same as this one, so it has consistency. Now we have a new pipe and a new junction, but why do we want this? Maybe it's because we had a customer that we didn't have here, so new customer here. This would be, sorry, that's incorrect, this one. This would be our new customer. To this customer, we can add a demand later. We'll not do it now, but just so you know, it is possible. We can add the cubic meters of demand that this customer has every day or every given period. And now we can connect this to the network. So we use the link tool. This dialog appears. And we say, okay, link catalog. It's a 63 pipe of plastic. We will set it for this customer here and accept. And now a new link is created. So this customer is already connected to the network. That's simple. And finally, we can also replace items. So we have this endpoint that's no longer an endpoint. Maybe we want to create a shoot of bulb in case we need to do some network cuts or some operations. So let's create a shoot of bulb with this replacement tool. We click on the node that we want to replace. It's no longer an end line. It's going to be a shot of bulb. We're going to keep the asset ID, but not the IPA values or the elements. And right now, it has become a shoot of bulb. So for editing, this is the basic. We can insert all sorts of elements. We can connect customers to the network. We can replace existing features. And now we could go back and we could start deleting these items if we want to retrace what we did. But we should go with a lot of care. We should start first removing the link, then we remove the customer, then we remove the arc, then we change this node back to an endpoint, and then we remove this last node. Not important that you know all of this, but just keep in mind that hierarchy is important and in the workflow. So if you draw in the incorrect order, topology will not be correct and the network will break. And then when you go to hydraulic model, everything will collapse. Another thing that we can do is to move items with topology. So if we have snapping enabled, now I can come here and say, hey, this valve is not here. It's actually here. And as you can see, the arcs are moving as well. But here's the funny part. If I save this now, let's say I save this, and the links are reconnecting to the new arcs. I don't have to do anything. All the customers are already in the new arc connected. So this will be the edit part, and now we can move to operations and management. Let's imagine. Let's say that I'm a field operator and there's been a leak exactly in this pipe. And I say, well, I need to do something. What do I do? This tool right here. Let's create a mincat, what Claudia was talking about before. This is a lot of information, but you don't need to know any of this right now. You just click here and it will draw a mincat. That's right. Well, it's not drawing.
Start by clicking the button of new mincat.
No, I did. New mincat.
The mincat. No, first. No, don't
Inside
don't
of the
close it.
dialog of the
Ah,
mincat.
okay.
Exactly. Yeah, exactly. Yeah. Thank you, Maria.
Most basic part. Okay, so this is a mincat. What do we see here? We see all the pipes that will be dry once we close these red valves. So the leak is here. If we close just this valve, it makes no sense. It makes no difference. There's still water flowing from here, the other side. So this valve is green because we don't need to close it. It just stays as it is. The red valves are the ones that we need to close. And these arcs will be dry because we have closed these valves before. And all these customers will be affected. So if we have right information and right connections with the real data of the customers, we can send notices or we can call the customers and say, hey, today from midday to 3 p.m., there's no water in this neighborhood because we will be doing maintenance operations, for example. And last but not least, maybe I have this valve right here closed, but then I go there and I see, hey, I cannot open the register, or maybe this valve is broken and it will not close. So, hey, flag this as inoperative. Mincat is extended. It shows us what we need to do to bypass the fact that we cannot close this valve. So, of course, many more people will be affected, but sometimes you can just not avoid it. If we save this mincat right now, clicking accept, we go to the manager and we will see that a new mincat has appeared in state planified. If we actually went to do this, we could check state complete or state in progress, and then it would change here. This is a bit more advanced though, so we will skip it. Now, hydraulic modeling. Hydraulic modeling is one of the big components of GISWATER and one of the things that people look forward to because it's a powerful tool. We can run models and we can see the results almost in real time here. We don't need to open any external software. So we can see here. This is the Go to EPA tab that we will not be using now, but you can export IMP files. You can execute the EPA software and import results. Or you can do these things individually. You can do everything at once, or maybe you are just trying to check for errors in your IMP file and to see if your topology is correct. So maybe you are only interested in exporting the IMP and you don't even want to run the model. You can also choose things in the selector, and you can also configure the options of the exportation to the model from here. Right now, to save time, we also ran two models before, the clean test and the demand scenario. We will see the difference now, but before we will check demand scenarios. This tab right here, we have one scenario where we have all hydrants working at 50%. So what this means is we can simulate the network with what we have in the network, the regular assets, and then we can do a separate simulation that's not going to affect our corporate GIS, where we say, hey, these hydrants or these points have this demand, and let's see how this affects the rest of the network. So from this result selector, I can see clean test, accept. And now we can see the maximum values for the arcs and the nodes. We can see the different pressures in the nodes symbolized from here, and we can see the velocities in the pipes. Of course, we can change symbology and look at other values. And then if we change the result and we say, we want the demand scenario, take a look at the pipes, for example. What's changing? Almost all the colors are different. And it makes sense because if we have a hydrant here that needs more water, it's taking more demand, it's gonna affect the whole network. It's not just gonna affect this one pipe where the hydrant is demanding water. So as we can see, we go from something very stable and very predictable to this scenario where maybe it's introducing a bit more complexity, where maybe we need to study, hey, this hydrant, do we need to put it here? Is it too close to another one? Do we need to make a double network to separate them? And then you start getting into different situations and different scenarios, and then you can go to the plan. You can go to the master plan, create a new planified sector, and you can start exploring new possibilities of the network. So what would happen if we put this hydrant right here? Or what would happen if we put a pipe that's double the diameter, maybe? And to showcase this, we will not create any of these sectors because it's a bit complex, but you can see from the selector, P sector, master plan 1 and master plan 2, we go back to the inventory. And if I check this one, you will see that one pipe or more pipes in this case are going to change color. This is yellow. This means this is planified. This is not the network that we have right now. If you take a look at this says polyethylene high density. If I uncheck, it's a 63 diameter. It's half the diameter almost. Master plan O2. The other one right here, also pipe replacement, for example. And the interesting part, new with GISWATER 4, is that we are just seeing these sectors here. So if I go here and I enable master plan 1, I will see master plan 1. But if I click on this button on the bottom left, I will change from production state to planified state. So you can see the color has changed a bit. This means that we can now edit this master plan. We will not do it because it's exactly the same as regular edit, except you are working with fakes, with future versions of the network that you don't have right now. We switch back to the production mode, and we can continue working with the network, altering what there is now and not altering all the planifieds. And finally, we get to the part that Claudia likes the most, the map zones, the algorithms. This is one of the most powerful tools. And here I would like to thank the database model and the developer team in BGO because they did an astonishing job making this work. We have this toolbox with these different bars. And in this particular case, we are going to master and map zones analysis. Map zones analysis can analyze the press zones, the district quality areas, district meta areas, or sectors, hydraulic sectors. In this case, we will do district meta areas. For only exploitation 1, why not? We don't need exploitation 2, so we only do for one exploitation. We can force open or close nodes, which we won't do now, okay? We can use planified sectors, and we can commit changes. This is very important. We do not want to commit changes unless we are 100% certain that this reflects reality, and this is what we want to do. There are different methods of constructing these map zones. In this case, we will do a pipe buffer. And this check is for dynamic map zones. This is an important concept. We can have static map zones if we commit the changes. This is the map zones scenario that we have and we take as real and we take as good. But then we also have dynamic scenarios where we can generate map zones based on the way that we are editing the network. This is an algorithm that takes into account already existing elements in the network, and I, as a user, don't have to do anything. I just check this box, run, and you will see what happens. It would be funny if now it didn't work. It does work. It does work. So we can see this valve is closed. All right. All of this is painted yellow. Why? Because it's this one district meta area. This is painted purple. Why? Because it's another district meta area that ends at this point. So this node parent for this other district meta area. So as you can see, 3-4 clicks and I can have a complete analysis of the network with algorithms, and I don't have to do much. I don't even know what I'm doing right now. So just click 3 times. Okay. I send this to somebody who knows what they are talking about. They validate or they don't validate. They tell me what to do. So this is a powerful tool for almost everyone to use. You don't need to be an expert technician. You don't need to be the manager in order to do this, or maybe you need to have the role and the permission to execute this function in the toolbox, but you don't need to be the one person in top. So it is important to see that these tools are trying to facilitate and make the process quicker. As Claudia said, very quick algorithm. As you could see, we run it now from 0 and it did everything manually. It's a lot of calculations in the background, so really amazing job. And while we are in the toolbox, we can see a few more details before ending this demonstration. We have operations functions. For example, we can calculate the reach of hydrants to see if we comply with the regulations or not. Or we can do flow trace analytics to see where the water is coming from or where it's going. This in urban drainage, we have more specified tools, but we will not show them here because it's a water project, this one. In the edit part, we have lots of checks for topology to see if the network is doing fine or not. Some tools for hydraulic model, tools for map zones with network scenarios, because we can also configure different items and different elements as closed valves or flow meters, and we could create different scenarios of the network for different district meta areas. If we close certain valves or something, this would be the dynamic map zones that we were talking about before. We have some admin functions, and then we have the reports. So we have some reports. For example, this one, it's going to tell us what nodes we have. So in exploitation 1 and exploitation 2, we have these nodes and this number. So 33 T nodes in exploitation 1, or 1 filter in exploitation 2. And last but not least, probably the most important button in GISWATER for managers, the one that overviews everything, check project. I'm going to run a check project and see what happens. I'm going to run system health check, not going to run any ignore verified exemptions because I don't have any. And we are going to run all the checks. What happens here? Check system. It's telling me versions, everything is all right. database data. Here it's going to tell me, do I have any critical errors in my network that won't allow me to work? Do I have any warnings that I have to consider, but they won't break the network? And additional information that maybe it's of my concern, maybe not. What happens now if I, for example, do this? Just a regular junction and I put it here and I don't care. Okay, new element, node, junction. What is this doing here? It's doing nothing. Why did anybody put this here? So I'm the manager, I run check project, accept. And now I cannot believe it. I think the node didn't insert. Maybe I did something wrong. It should appear a critical error right here. Well, things of the live stream doesn't always go as planned. Let's try with another item. For example, let's add it somewhere else here. And now it should appear the critical error that we have an orphan node. That means a node that's not connected. Well, it doesn't show as critical now, but it's a warning. New warning, as you can see, one orphan node. So as you can see, this check project also updates in real time. If you do anything with the network that's not okay, your manager will know. And the manager can also trace back to what node this is, who edited this node, who inserted this node, and ask real questions and important questions. Like, for example, why is this here? Maybe you are correct and this is here, but what is happening? What is this connected to? Why doesn't this have topology? If something breaks, we will know at the same day that it breaks because we can run check project every day or every 6 hours or every 2 hours. And we can know if anything has changed from the previous check project that we did based on this warning log and this information log. And I think that would be it. Short time for a demonstration of GISWATER. I had to rush everything, but I hope you could see the capabilities of the tool.
Thank you, David. We do have some questions. I think if you can see the screen. So the first question we have is, do the customer links always have to be a straight line? What can you do if the connections to the customer area are in branch form where customers tap off from a line that's picking from the main? So David, would you kindly answer that?
Yeah, the links are actually fictitious pipes, so they do not represent exactly the pipe in real life underground, but we can ignore that in a way. We know this customer is here, we know the network is here, and the connection, it goes somewhere, but the important thing for the hydraulic model is that we know what pipe it is connecting to. So maybe it would do like a Z form or a Z shape, but in the hydraulic model that is not relevant.
Anyway, David, it is possible to make a link with a customized shape. It is. You can do it. I mean, it's very easy just to let the GISWATER to connect it with a straight line. But there is the possibility to choose the to choose the link to do the real track. First of all, and second, it's very interesting that in GISWATER you can connect uh, um, this connects to other connects. So in the question was something about if the connections are in branched form.
Yeah,
So
if you have
there is the
many
possibility.
hydrometers, you can
No.
contain all these hydrometers in a single connection.
Yes. We have really limited time. The webinar was supposed to go an hour, but since it's amazing, the whole GIS water features, it will take more than 1 hour for sure. We will try to answer a few more questions. Um, well, the if a utility wants to start small with GIS water, where should they begin? David?
Maybe this one is for Claudia. She works in a utility.
Yes, Claudia?
If a utility wants to start small with GISWATER, where should they begin? With the topology.
Yes, the topology is always the hardest, but GIS water makes it easier and
But
simple.
GIS has tool exactly. It helps to have the correct topology, saying where the errors are, or even automatically fixed them.
Yes, of course.
So
Thank you.
it's starting to, and also it has a real an easy way to import the network from other softwares that you have it drawn.
Hmm. Yes.
So there are tools to so it's yeah.
The next question is, can it integrate with other modeling software apart from AppNet or Swim? Well, I could answer that because I have been doing hydraulic modeling using both AppNet and Swim. And what GIS Water does is having the INP file that works in any hydraulic modeling tools. So you just need the INP file and you can run the um, any tools of your choice with that INP file. Of course, with AppNet and Swim, we have this whole database configured so it can get the information, run the swim in the backend or AppNet in the backend, get the results, and then show it in the GIS interface. But if there is something that needs to be integrated, other tools, it is a possible. The whole open source thing is, nothing is impossible, so you can give it a try. The next is, how do you see GIS water evolving in the next few years, especially with digital twins, real-time data, and automation? Maybe Claudia would answer that.
Well, the future is here, in fact, because BGO are working on a digital twin, so they are on it.
Yes, of course. The next question is, how do you add new customers in batch format in cases where you have, I think, a list of 50 new customers? What is the fastest and easiest way to have them added to your network? David?
Oh, this one is not a fun one to work with. No, you can have a CSV and you can add the customers into a table in the database. Then you can set geometry to these customers. You can use maybe an algorithm to go from an address to a point in the GIS, or maybe you have coordinates. Uh, it's a bit of a complex process, but it can be done. And yeah, if you
Hmm.
add everything into a table in the database, you can do it in like batch format or adding maybe 50,000 customers at the time.
Great. I think you can answer the next question too. Like, is there integration with mobile application? And I think we can combine the question with
Yeah.
for field data collection and asset inspection or maintenance activities, so
And
GIS
the
Water
SCADA
provide.
and IoT one, it's everything is related here.
Yeah.
So we can connect all of this to PostgreSQL, yes. We can have a field operator with QField taking pictures or taking notes or measurements or anything. Then we can
Hmm.
have sensors in real time giving us data and loading this data into the database. And the mobile application that we don't provide, but it can be used with QField.
Yes, I think in fact we do have done this with our one of our projects where they have the Q field and people go in the field and collect the data. And for the asset inspection, like for certain things like the mean cut one, you can just have the QGIS web client open in your phone browser. You just click on the pipe and see the mean cut, and I think you can add the visits, click a photo and just put it right there. So yeah. Are there any questions? I think I saw a pop-up comment like,
Namu, I see
yes,
there is another question, and I would take advantage of it to add something
yes,
more about the digital twin. And it's
of course.
about, can GISWATER work with the real data, with real-time data like SCADA or IoT sensors?
Yes.
So, what's the brilliant idea that BGO put inside was that in order to have the digital twin, um, uh,
Claudia. Oops, that was like the
Yeah.
climax part of the answer, and she just froze. Hola, Claudia. I think you're lagging. Okay, while Claudia gets to the meeting, I think there was a pop-up question where there was like, can you connect with ArcGIS, AppNet, and simulations and stuff? I think GIS Water, the whole thing about, is it me? No. So the whole thing about open source GIS Water is it can be interconnected to different things. So the main thing, we have the database, all the information, and then you have the hydraulic modeling, the GIS interface. So it doesn't matter what GIS interface it is. Of course, we want the algorithms and the solutions that we develop and provide would be open source and not pay the proprietary license. Um, but yes, it could be possible
No,
if
but
that.
this is an interesting question. You
Mm,
can actually export your network from GIS Water to ArcGIS, no
yes,
problem. You can just
yes.
do a geo package or shape files and
Hmm.
send it all there. And if the database is there, you can also connect to maybe a geo database from ArcGIS and do all the migration. Should be
Hmm.
possible.
Yes. Yes, Claudia, you're back. You can answer. You're mute. Yes,
Sorry. Yeah.
no worries.
No,
Yeah.
yes. So, if GISWATER can work with real-time data like SCADA or IoT sensors, it does. And what GISWATER use, it's the sensors things API server. It's a QGIS provider now, and it is used as a bridge because every company has their own SCADAs. So what we GISWATER will have is a sensor things component. The implementation is Frost, and where the IoT data that are used for the hydraulic models and are used for the digital twin. So the place for this IoT sensors data is the sensor things API server. That is QGIS data provider. You can find it in on QGIS among other data providers. And the way to visualize and to interact with the data, it's really very easy through
Yes.
QGIS. Mm.
Yes, of course. Like I have been working with AppNet and Swim, and then I don't like the interface, to be honest. If I'm just working with AppNet and Swim, of course it's nice, but with GIS it's much more. And with additional tools of QGIS, you can do much more, like visualize with colors and everything.
Yes.
I think post-processing of results is really, really important when you're basically showing it to decision makers or like public or anyone specific. So I think in that case, having this whole GIS interface with GIS Water is amazing. We have one another question here. Where does app? Oh no, we have more. Um, does AppNet and GIS Water similar or which show much difference? David, would you answer it?
Yeah, I think everything that you can see in IPANET you can see in GIS Water because the results from IPANET are imported into GIS Water. And the best thing is that you can work with these results, you can process these results, and you can gather insights of these results from the GIS. You don't need to leave the interface. So you can prepare the model in the GIS, which is much more comfortable and easier than in IPANET or IPASwim. Then you can run the model and you can check that the model is correct. You can run the model and you can see the results all from the same interface or all within a few clicks.
Mhm.
And yeah, you can see anything that you could see in IPANET and probably more.
Yes, yes, of
In fact,
course.
GISWATER is not it's not a substitute for EPANET. GISWATER, what it does is creating the INP and execute the EPANET.
Exactly, exactly. The whole modeling results are from AppNet itself. GISWater just gives a face in GIS interface,
Yeah.
QGIS. Um, I think the answer with integrating ArcGIS is all done. Is there any dashboards available to visualize different KPIs for the asset management system? I think Claudia would.
I don't know what a KPI is.
Key performance indicator, maybe?
Yes, I think so.
Are we
I
referring
don't
to
I
this?
don't understand the question.
So, well, we can use a link from GISWater to a dashboard and to a business intelligence, basically.
Mhm,
Yeah, we can. The asset manage was last week the webinar, but yeah, we can use the data that we have in GISWater to prepare dashboards and to visualize the data, and then to turn it into uh, integrated in the decision making processes.
mhm. Yes, I think as we showed in the first slide of GISWater, the whole architecture that it can be interconnected to any of the platforms. So dashboards is not a new thing to be connected. We do have customers who have their own dashboards and they link from GISWater to those to show KPIs. And for the asset management system, of course, we do have another set of add-ons of GISWater with the asset managed schema, and then it basically provides you information about assets and also when to replace supply, multi-criteria. That was last week. So yes, of course, that can be done. A question for Claudia.
And Namu, I would add here, because now I understand the question, that BGO provides now APIs that can be called from external applications that are prepared
Mhm,
for having dashboards. What GISWater and GIS does is giving the topology data,
mhm.
and now GISWater has its own APIs that can be used from the external applications.
Yes, definitely. We do have one another question for you, Claudia. What things you do now with GISWater that you could not be able to do before? I think this is
I
specific to water utility as you work in water
yes.
utility sector.
Um, it's that with the GISWater, GISWater gives you like these smart analyze algorithms for having the map zones, uh, for the Mincat also. What it is very important with the GISWater is that if you want to use EPANET or SWIM, EPANET and SWIM don't have an easy import way of the data to bring all the data with their characteristics into the EPANET. So what GISWater does is preparing this file to execute EPANET, but even more, GISWater has inside of its database the tables with all the parameters or variables that are used in EPANET and in SWIM. So you can personalize all the parameters that you need to execute for your models. You can have them in the same place where your network is, because I always say that having a model, a hydraulic model, and calibrating it, it's very difficult. But even more difficult is then to keep it updated. And with the GISWater, you can have once you have a model, you can have it updated, because every data that is related with the hydraulic model, it's in the same place where the inventory network is.
Yes, we do have questions. I am so happy like people are participating in the webinar. In the chat, we have question from Steve. Is there any thought of branching out to electric? Um, oh, sorry. Yes. Can you? No? Okay. Yes, the question is there any um, thought of branching out to electric or ITS or communications?
I don't think
Yeah,
so
I always
for
ask
now.
Bejo why they don't do it.
I think maybe this is a discussion for another time.
I mean, the principles are the same, so
Yeah,
it could be done. It could be done.
Yes. Well, I think,
Claudia,
as I
let's
said
let's
before.
not get ahead of ourselves. Let's not speak too much.
Okay, I think Percy wanted to ask a question, but she could not. Well, in the Mentimeter, you should be able to put the question, but I am not too sure why it's not. Okay, question related to asset management will be possible to link to the webinar which was held last week. Yes, we are trying to make the video because we do have these confidentialities. We have to blur all the participants' name. But yes, as soon as we do that, we would have the recording. But also, if you want to look into our short videos, we do have our YouTube channel where we put like short series where how you can get started with the tool. So for the asset manager, you do have that one. So if you can go to the YouTube link, that's also possible to know more about it. Okay, I think that's all. Well, it was a fruitful session, I hope, for everyone. So we would like to know how useful was this session for you. I
I'm
hope very
gonna
useful.
I'm gonna answer the last question that got in last second. Can we share the same project two-person at a time and use and bring changes at the same time? Not the same project in QGIS, but if you work from two different projects against the same database, you are able to work at the same time. So, for example, in my case, I have worked with 3, 4 colleagues at the same time, all against the same database, all working different sectors. And we have everyone their own QGIS project. We all have the same and we all see the same in our QGIS project. And it updates in real time as other people are making changes. The only thing important is to know who is doing what and not to overlap.
Yes, it is a matter of giving roles and permissions of what the person can do in the database. And as long as you have that set out clear, then you can work with multiple users at a time. Well, thank you. Yes, indeed, it was a great the fact that most of the people are still here. Thank you very much for being here in the whole webinar. We are really glad that you liked the presentation. Of course, GISWATER is such a huge tool and there are a lot of processes and it's impossible to share everything in just 1 hour webinar. But I hope you like it. If you want to have trainings or more information about it, you can definitely contact with us. We have specialized trainings both in English and Spanish. So yes, you can of course contact with us to learn more about GIS Water. Next week we do have another series of FIBA GIS, which basically combines the urban drainage flow, the 1D and the 2D flood modeling. So yeah, if you are keen, just make sure to register and then see you in next week. Thank you. Thank you,
Thank you.
everyone.
Thank you, Bobby.
Thank
Thank
you,
you, everybody.
Claudia.
Thank
Thank
you,
you,
Thank you very
David.
Nami.
much.
Okay,
Bye.
bye, everyone. Have a nice day.
Goodbye.